We're going to solve for a logarithm in two different ways. And when I say two different ways, it's really the exact same way, just maybe we think about it differently. Let's work on our first method. We're going to take log base 2 of 16, and we're going to figure out what that equals, right? Because logarithms are not as intuitive to me as exponential equations. So we can rewrite this as an exponential equation. 2 to the x is equal to 16. 2 to the x is equal to, I can write 16 as 2 to the 4. So then by injectivity of the base 2 exponential function, x has to be 4. Okay, let's go over here and think about doing this in a different way. Now we know that exponential functions are undone by logarithms. So if I plug a logarithm into the base of an exponential function, as long as the base is the same, then they should undo each other. So let's take this equation and map it into the 2 to the x function. So I'm going to take 2 to the log base 2 of 16. That will be equal to 2 to the x, right? If these two things are equal to each other, then if I put them both into the exponent of 2, then that should also be equal. And now here I have a base 2 logarithm plugged into a base 2 exponential function. So they undo each other. I just get a 16 out. And you can see that it puts you at the exact same spot. So x has to be 4. So the big takeaway here is if b to the x is equal to y, you can rewrite that as a logarithm. Log base b of y is equal to x. And you can go in either direction, left or right, right? That can be helpful to solve equations. But then also, if you have 2 to the x, and then you plug that into a log base 2, it gives you back just an x, because the logarithm undoes the exponential. Also, if you take a base 2, if you take a logarithm base 2, and you put it into the exponent of 2, they undo each other, and you get back x, right? In fact, nothing special about 2. It could be any base. Log base b of b to the x is equal to x. And log base b, if I put it into the exponent b, then it gives me x.